Okay, so I have been promising for a while to make this video. I appreciate it's probably a little too late, although I've spoken to you a lot about this question, and I know a lot of you now know how to do it. But for those of you who don't, let's go through it line by line. So this is question 5 on the mock paper, and the whole question is about taking a non-linear relationship, in this case an exponential one, converting it into a linear relationship or linear equation, and then using the data to extract the gradient of that straight line and the intercept, and then doing an additional calculation. So I'm just going to read the question. Okay, Thomas gets bitten by a venomous snake. Doctors are satisfied that he will make a full recovery, but they decide to monitor the level of venom in his blood. The table below shows the concentration of venom measured at intervals over a 24-hour period. So here's the data. You'll notice I've got an extra column. Oh, I wonder why that's there. And here is my relationship. CT equals C naught e to the power minus lambda t. Okay, I hope that's clear. And that says where time is t. C naught is the concentration of venom in the blood immediately after being bitten, and this C is the concentration of venom in the blood after a given time t in hours. Lambda is a decay constant. Okay, now if you were to just draw that, what would it look like? Right, so I've given you this. I'll write it out again here. Okay, C T is equal to C naught e to the minus lambda t. Okay, now this confused some people, right? So forgive me for this. This is just some nomenclature here. This does not mean C. This doesn't mean C times T. This means the function C, concentration at the time T. Okay, I could also have written it as C subscript T is equal to C naught. And actually, I think that's probably a better way of doing it. So I'm going to continue that way for the rest of this question. What would this graph look like? Well, if I was to draw this data, and you can go ahead and do this using the data I've given you. If this is CT and this is time, I'm telling you it's an exponential decay. So I've never done an example with you on exponential decay before. I've only done examples where you have an exponential onset like that. Okay, but it's the same thing, just in reverse. So this time, instead of starting off with next to nothing and increasing exponentially, we're starting off with something and decreasing exponentially. So it's going to look like this. It's going to taper off to nearly zero there. Okay, so that's my equation of a line. How am I going to get what I need to get? Now let's carry on reading the question, because I haven't told you what I need to find out yet. I'm asking you, using all the data, right? So that should be a big hint that you're going to do a linear regression on your calculator. And of course, I've then said, and your calculator, calculate lambda and C naught. So we are going to calculate this and this, okay? So how do we do that? So this is an exponential. How do we convert that to a linear relationship? Now, it's got an exponential term in it. Now, if you see an exponential term, or an E, or an EXP, you should be thinking natural logs, okay? Because if I apply a natural log to e to the power 1, that's 1, okay? That's how I'm going to get rid of that horrible exponential term there, okay? So you should be thinking natural logs. Right, so let's take the natural logs of both sides. I'm going to write that down. Take ln of both sides. Okay, so let's do that. Ln of CT is equal to ln C naught e to the minus lambda t. Okay, step 1. Well, this is okay. This is just ln of ct. Okay. Now here I've got two terms in this bracket here. I've got the c naught and I've got the e to the minus lambda t. So that's similar to ln a times b, where a is c naught and b is e naught, e to the power minus lambda t. That is equal to ln a plus ln b. So we can rewrite this as ln c naught plus ln e to the minus lambda t. Okay, so now this term's okay. I've got this one and I've got this one. What about this one? Right, let's write it out again. ln ct equals ln c naught. Now this time I can simplify this using this rule. Okay, look familiar? So I can fit it all on one line. So I can simplify this by taking the minus lambda t down. Now it's already a plus, but if I take this whole exponent down, I've got to take down the minus sign as well. So that becomes minus lambda t ln of e. Now what's the ln of e? It's 1. So I can rewrite this as ln ct is equal to ln c naught minus lambda t. Okay, and now I've got my x variable, which is actually time, not dependent on anything except this factor lambda in front of it. So this is a linear equation, right? You should recognize that. So I could rewrite that as y equals mxc. Okay, where in this case y is equal to ln ct, c is equal to ln c naught, and m equals minus lambda. Make sense? Right. Good. So that's important. You should know how to do that. Now we've got to go ahead and work out what lambda and c naught is. So I need to calculate what m and c is by putting all that data into my calculator and doing the linear regression on it. So what do I need to put into my calculator? Well, I need to put y data and I need to put x data in here. So the y data is ln of ct. So this is ct, this column here. So I can't put that into my calculator on its own. I've got to put in the ln of ct. Right, so I need to calculate ln of this value and then ln of this value and so on and so forth for this entire column. That's why I've left you an extra column. I am going to cheat because I've got these values already. I know it's 4.15, 3.20, 2.87, 2.71, 1.2, 0.69 and 0.26, and I've been very, very careful all along to use the correct number of significant figures there. Right, so I've got to put this into my calculator now. So I'm going to put my y data in, that's this column, and then my x data, which is my t column, my time, and then I'm going to do that. So let's do it. Let's just do it. Get more light here. Okay, so first thing, y column, I'm going to go shift mode. I'm going to go, oh, that was the wrong one. Shift mode stat. So I've gone mode and then number 2, and I'm going to do 2 for a straight line, a plus bx. Okay. So obviously on your calculator, your b is your gradient and a is your intercept, so don't get those mixed up. I'll come back to that in a second. And press number 2. It's going to give me a data table. I'm going to put my x data in first. So that's 2.0 equals 4.0 equals 5.0 equals 8.0 equals 14.0 equals 17.0 equals and 20.0 equals. Right, and then I'm going to put my y data in. 4.15 equals 3.2, 2.87, 2.71, 1.2, 0.69, 0.26. Okay, then you press cancel, and then you press shift, stat, which is number 1, then you're going to do number 5, reg. Okay, I want the gradient first, that's a b, so I'm going to press 2 and equals. Okay, and I get an answer which is minus 0.203. I want my answer to 2 significant figures because that's the best I can with the data given. Okay, so my m value, m is equal to minus 0.20. Okay, but m is equal to minus lambda, right? So that's basically saying my lambda is equal to 0.20, right? I can do better than that. I can fill in this bit here, look. So lambda is 0.20, 2 significant figures. Great. What about my C0? Well, remember, I can work out my intercept for my calculator now, but my intercept isn't C0. My intercept is ln C0. So I know what that is by doing shift, stat, reg, and then I'm going to do 1 this time, equals 4.19 or 4.2 to 2 sig fig. Okay, can you see that? I've done it on there. Now, I need to get C0 from ln C0. Okay, so you should know that to go from this to this, I can just do e to the power ln C0 is equal to C0. Okay, so that's going to be 4.2, oh sorry, e to the power 4.2, which gives me 66.68. Again, I do that to 2 sig fig, so that's 67. Okay? Right. So, I've got the hardest bits out. I've got my lambda and my C0. Okay, my next question is, how much time to the nearest hour would it take for the venom concentration to decrease to a level below 0.5 nanograms per milliliter? Okay, so let's have a look at my linearized equation again. I'm going to write it down. ln CT is equal to ln C0 minus lambda t. So I'm trying to work out how much time I need to get to a CT of 0.5. Okay, so what I'm going to do, I'm going to rearrange this, what I did earlier, to solve for t. So let's do that first. Let's do ln CT. I'm going to take the ln C0 over. Okay, and I'm going to divide by minus lambda. Okay. And that's going to equal t. Right, so let's plug the numbers in. T is equal to minus ln, remember what CT is? 0.5 minus ln of C0, which is 67, all over 0.2. Let's do that on the calculator. Ln 0.5 minus, oops, don't do that, minus ln 67 divided by 0.2. It's times by -1 as well, isn't it? Okay, so it's 24.48, but to the nearest hour, I'm going to call that 24 hours. Okay? Right, done.